Welcome back. So continuing on the same pattern, what we'll do today is test-driven development for a calculator app. So we're going to create some minor things, and proceeding from that blog, we are moving to a different blog. And today we're going to just learn from this digitalcatonline.com, and they have a very good description of how Pytest works. So ultimately, my goal is to learn all the scenarios of how Pytest can be done, so that in case I have to mock something or use a different scenario or return something for the function, I'll be able to do so. So let's assume that a calculator class exists, and we have two classes which I created, calculator.py, testcalculator.py, and as you can see, everything was already done. So bring this back after practicing a bit. So let's see how I do. So first of all, I need to import, right? So from calculator, what not cache tools. Oh my goodness. Import. Let me call this just simple calculator. And I just want to test adding two numbers. Simple add 1, 2, 3. Now if I run this, and I can do pytest dash svv. So svv is a way to give more verbose answer and give all the statements one by one. Right now it doesn't recognize it, so that means I need to create a class, and I can call it simple calculator, and for the time being just pass. So let's see if it passes. It does pass. Pass in the sense there's nothing there, but the previous test or the scenario we were in passed. I'm sorry for being terrible. That's why the tutorial is named terrible tutorials. And then we have simple calculator has not replied. So let's create a new function which just does add. And again, before we do this, let's just pass. So that's to show that this is possible. And yes, now it's only asking for this. Now we remove this and expect what we were expecting. So return a plus b and everything passes. Great. As you can see, there's also the string manipulator which we created earlier, which is still there, which is fine, but it's showing every possible other test, which is awesome. Now the requirement for this add two numbers based on the block is that you can add more than two numbers, and that's why the function was named add two numbers, which means so add three numbers, because if I can add multiple numbers, three numbers should also be there. Let's see how good Copilot does. Reasonable. I can take that. Now, of course, if I run this again, it will fail because there were three positional X's, but four were given, which makes sense. So how do I change that? Now, the good thing about TDD is what we learned right now. So seeing that test, I'll just create C and simply add C, right? Which makes sense. That should be working for this test, which it will. It absolutely will, but it fails on the other test. So if you see, it failed on line 5, which is the test in the second one. Now, if I only want to run this second one, I just need to run a different. So there's two ways we can do this. One we can do is give us dash k. This allows you to specify a matching name. So if I want to just test add two numbers, so let's test that, it still fails. And for the time being, let's just remove this and then again test it. This time it passed, but now if I just do three numbers, it will fail. At least it should fail. Good. Now let's go back here and let's again test this. It's still failing. So at one point there should be only one test failing. Now if I run the other test now, it will pass. That's good. That's what test-driven development is for. Now, so in Python, as you already saw, you can give 0, or let's say what the AI was telling us, or Copilot. And here, if we run this, it doesn't work. So Copilot wasn't very useful here. So we should be giving 0 because it's expecting an integer value. So now if we give 0 and if we run this, it passes. And if we run all of them, Everything passes. Great. Now, again, the requirement is not two numbers or three numbers. It's multiple numbers. So that means we can also add four, we can also add five, six, and so on. So one way which they describe is could be you can do this, or you can go on and on, or the better way to do it is first let's test for it. So def test add many numbers. Now here there is an option they're giving by many numbers 15, right? So they have given 5. Now if I was just testing for this, I could have easily done. So let's first run this just to show. If we just run this and we give the same thing as what we were doing earlier, and now we run this, this will pass. Great. So that means this does not signify what we are trying to do, because the moment we try to add a sixth number, this whole setup will fail. So that means we need a better way to test these numbers. And one way we can do it is that we can use numbers between a range. So if I do this, this means that there can be numbers from 1 to 100, which is awesome. And now if I want to add all of these, I can just give them as numbers. This means that all the arguments are added here and using star. So the whole array list or whatever, however you want to use it, it's coming as one argument. And now if we add all of them, thank you Copilot, it tells me that it's 4950, which is beautiful. Now if I run this test, it will fail because it's expecting 6, but we were given 101. This is something I thought I would never see, that I'm talking about 101 arguments, but here I am. Just fine. This is our current requirement. So again, so instead of A, B, and everything, let's change this to numbers. And I think you can just do star numbers. And instead of adding them, you can just do some numbers. So let's run this. Everything passes. Fantastic. Isn't that great? Okay. So similarly, now let's test for subtraction. Oh, Copilot already knows all this. Maybe it's listening to me. So this is the scenario, and if we run this, it will fail because there's no uh, function for that. So let's create the function. Um, Subtract. I can pass it, but now I have understanding that how it's working. So let me just run it. Make sure this passes. Great, it passes. That's a very simple scenario for subtracting two numbers. Now there's a question which might occur, that in the string manipulator we were using these return string and everything, but in calculator we are not doing it right now. We can, if that's what we were expecting, but we don't want to just give string values again and again, and we'll get to know more as we continue doing this. But for the time being, let's try to multiply now and see how that goes. Ooh, that looks like a good test. But if you run this, I believe this will still pass. So one thing about test-driven development is, if a test is not helping you pass or failing something which the other function did not do, it's not really necessary. So sorry, Copilot, I'm gonna reject your suggestion, but I do want to multiply two numbers. Now it's giving me a simple example which it failed. Sorry, trying too many shortcuts and not doing it very well. So I do this, A cross B, it's great, and it passes. Awesome. So we are able to multiply this. Um, Now, similarly, we can do multiply three numbers, multiply four numbers, but we don't want to go into that whole thing again. So instead of that, let's just do test multiply many numbers, right? So we are trying to multiply many numbers. We face the same way. So we give 10 numbers, which makes sense because we don't want to multiply 100 numbers, which will be a huge number, and I don't want to deal with that. So that's, I'm assuming this is the right number when you multiply 10 to 1. So now if I run this, it will fail because it's not expecting 10 arguments. So that means similar to what we did earlier, we can numbers here, which is great. And then now we can either do, oh, we are doing recursion here. Interesting. Let's see if this works, first of all. Wow. Okay, so that's one solution for sure. What you can do is it's either multiplying to itself, and if not, it's checking if the length is equals to 2. This is what they'll do. Else, it will multiply and it will just keep on going until you get the. So the first instance it will take 9 elements, and then next time 8 elements, 7 elements. So it will keep trying to multiply. So it will start with 1 into whatever the array with the whole function with 2 thing will go. Oh, this can be explained well here. So right now it's okay. Thank you. Let me also give 10 because it's there. So when the first multiply goes, it goes like this. Oh, that is exactly what's happening. Thank you for explaining that, Copilot. Now we multiply. This will be the last thing it multiplies, and the result of this will get be multiplied by this, and so on and on and on. So this is a great solution. I don't have a problem with this. But just because it looks great or just because it is working great doesn't mean that we have to do it. One thing which is very important when we are working is readability. Now, just because we are using a calculator app, this may seem very fancy and may work, but there are easier solutions to follow on this without sacrificing the time or space constraint. So there is a existing function or existing thing which we can use called reduce, which is going to be doing the same thing but has a better understanding. So what I can do is I can have a simple multiplication, which all it does is cross A cross B. So that's the simple multiply. And now instead of using this fancy thing, all I'm going to do is I'm going to reduce. Oh yeah, I'm going to simple multiply with numbers. So I'm going to send that there. First of all, let me add reduce, which should be func tool import reduce. Okay, now I'm confusing. No wonder my terrible reading is coming into picture right now. Awesome. Um, so I guess this should be inside here. I'm a little confused about this. Let me. Oh, okay. That was it. That was one way to do it. Beautiful. So coming back to reduce. So reduce comes from map reduce, and it is used for basically what we did was this recursive function in a similar way. Reduce kind of goes one by one and kind of keeps reducing it. Um, but you can find more information on the website if you want. I'm not going to go deep into it because that's not what we are focusing on, but that's more. And similarly, you can also refactor as we are going. One thing which I thought about refactoring was we don't need really this case, but I'm going to keep it here because it gives a good example of how things are going. I'm just going to keep it as ridiculous as it looks right now so that we have a simple file ready. So that was it for this one. In the next, we'll go through part 2 and all the other scenarios of TDD which we want to do.